Hello, geometry. Welcome to topic 11, 2 and 3-dimensional models, lesson 11.1, 3-dimensional figures and cross sections, right? So we are getting into our 3D chapter, which is going to focus a lot on volume. We are going to focus here on 2D cross sections as well, okay? Now, when you think of a cross section, think of it as a 2-dimensional slice of whatever you're working with, right? So think about a cucumber. If you cut a cucumber up in slices, or a carrot, if you cut it slices, that's what we're talking about, right? Now, before we get into the 3D figures, let's just go over two basic 3D figures you're going to work with. The first one's called a prism. So when you work with a prism has two identical bases, two congruent bases. So for instance, if I start with like this rectangle, and then I make that same exact rectangle. If I connect it, right, this is called a rectangular prism, right? Now the bases don't have to be the top and bottom. So like in this case, I made the front and back bases, right? But the bases are two congruent bases. And then if you look at all the other sides, they're also rectangular, right? So we call those the lateral faces. So we have rectangular lateral faces. So in a prism, or in a solid, you have the base, and then you have the lateral faces, the ones that go around. Okay. The other type of figure is called a pyramid. So for a pyramid, again, has a base, so I'm going to use a square. But then instead of a second base, it only has one base, and then it has a point, right? And all the vertices of that base go to that point, and this is a pyramid. For a pyramid, you only have one base. And again, the shape of the base would be one shape, and then the other lateral shapes are now triangles. So you have triangular lateral faces. Triangular. So there's your quick catch up on 3D solids moving forward. Okay, so this first slide here, we're going to talk about this guy Euler and his formula. Okay, so it says, how many faces, vertices, and edges does each prism contain? Do you notice any patterns? So again, we're going to try to develop Euler's formula. So what is a face? A face are the 2D planes that make up your figure. So these are the triangles, the rectangles, the pentagons, hexagons, whatever. The vertices, that's the faces. The vertices are the points, the corners, right? Of your planes. And then the edges are the segments that make the outlines of your planes and are connected by the points. So if we take a look here, all right, we're going to look for a pattern. This pattern is going to involve addition and subtraction. So in this first figure, right, this is a triangular prism. Two triangular bases and then rectangular lateral faces. There are two bases and then three lateral faces. So that's 5 total faces. There is 1, 2, 3, 4, 5, 6. Each base has 3 vertices. So that's a good way to count. So 2 bases times 6, right? Or times 2 is 3 times 2 is 6. And then edges. We have so each base has 3 edges. And then you have to have an edge connecting the base's corresponding vertices. So that's going to be 9. All right, so the question is, can you use addition and subtraction to find a pattern? Well, let's do another one. All right, let's do the rectangular prism. Okay, so we have, let's use the top and bottom as the bases. So you have the top and bottom faces, and then the 4 lateral faces, that's 6. The top base has 4 vertices, the bottom base has 4 vertices, that's 8. And then again, you have 4 edges here, 4 edges here, but then the 4 edges connecting. So 4 times 3 is 12. Okay, so again, looking for a pattern. I think I see one, but let's do one more. Okay, and let's do the pentagonal prism. Okay, so it is a pentagon. Your top and bottom are pentagons. That's 2 faces, and then there's 5 lateral faces. 2 plus 5 is 7. The top base has 5 vertices. The bottom base has 5 vertices. That's 10. And then your edges. Bottom base has 5 edges. And then top base has 5 edges. Then you can connect them with 5 edges. That's 15. So if you look here, right, if you take the number of faces, let's say 6, and you add 8, that's 14. 14 is 2 more than 12. So if you add the faces and vertices, that's going to equal the edges plus 2. 12 plus 2. 14 equals 14. Let's try it with another one. Let's try it with the first one. So if we go 5 plus 6, that's 11, right? Which is 9 plus 2. 11 is 11. It works. So this is our formula here. You take the number of faces, you add it to the number of vertices, and that equals the number of edges plus 2. And this is Euler's famous formula. I remember proving it in college, but I'll spare you the agony. Okay, so here's your formula introduction to Euler's formula. So for Euler's formula, the sum of the faces plus vertices of any polyhedron. A polyhedron is our 3D solid, right? 3D solid polyhedron. Not involving circles, have to be straight edges, is going to be 2 more than the number of edges. Okay, so let's see if we can apply it to a picture here. Alright, so example 2 says apply Euler's formula. To make a polyhedron-shaped game piece using a 3D printer, Juanita enters the number of faces and edges and vertices into the program. If she wants a game piece to have 20 faces and 30 edges, how many vertices does she need to have? Euler's formula, faces plus vertices equals edges plus 2. 20 faces plus, we don't know how many vertices, equals 30 edges plus 2. So that's 20 plus v equals 32. Subtract 20 on both sides. V equals 12. It needs to have 12 vertices. Now this is tough, right? If you look here. But we can try to count them all. Alright, so we have 1, 2, 3, 4, 5, 6 up there. So this is very much like a a pentagonal prism in the middle here, but then you see that you have also this pyramid shape up top. So and the pentagons don't line up, they're twisted, because like see how this point is not directly above that one, it's shifted over here. So it's a pretty weird shape. It's like a twisted pentagonal prism with pyramids on the ends. But again, there's 5 vertices around that, base of that upper pyramid plus the top point, and then there's 5 vertices here around that bottom base plus that bottom point for the pyramid. That's 6 and 6, which is 12. So there you go. All right, that's the end of video 1. Video 2 is coming up.